Hello everyone. So today we're going to talk about this problem. It's a majority element problem. Okay. So in this we are given an array of size n and we need to return the majority element. And what is majority element? It's an element that appears more than n by 2 times. Okay. So n by 2, which is floor here, you may assume the majority element always exists in the array. So there is always exist majority element, okay, which means greater than n by 2 times. Okay. So example is this one. Nums we are given 3 to 3 and this value is 3, correct? So what is this value? The floor of n will be 3 by 2, which is 1. Okay. And any element appearing more than one time will be taking that output, will be taking that answer. So in this 3 appears 2 times, so we are taking that out here. Here in this example n is 7, floor will be 7 by 2, 3.5 will be 3, correct? Any element appearing more than 3 will be taking that output or answer. Okay, so here 2 is appearing 4 times, we will be taking that. Okay, so these are the constraints here, and the follow-up is nothing but you need to solve this problem in linear time and order of 1 space complexity. Okay, so let us try to discuss the approach and then we'll be solving this problem. So here is this idea. So we'll be using Moore's algorithm. Okay, so what is Moore's algorithm? Basically you'll be taking two variables, one is majority and one is count. See, you are sure that there is one element which is appearing more than half of the times. Okay, so if you are going to be just trying to nullify elements, like 2 nullified with this, 2 nullified with this, then again 1 nullified with this, so you can see one element or one unique element will always remain. Okay, so that is the basic idea behind this. So let us try to do that. So first, initially we'll be having majority element, the starting one, okay, index 0 here. So this element will be setting as majority element and the count will be 1 for it, correct? Now we'll be starting our for loop from here, we'll go up to the last, we'll check. Okay, so 2 is given, so 2 you have 2 is already present as a majority element, so we are going to be incrementing our count from 1 to 2, so 2 appear 2 times, then we are at this position. Now 1 is appearing, okay, but you can see count we already have 2, so in order to nullify we'll reduce the count from 2 to 1. Okay, and we are at this position. Again we need to nullify this 1 count, so up to this point we this is nullified to 0, so up to this point everything is nullified. Okay, now at this position we are having a new element, so you can see we have 0 here, so whenever we are having count 0 we'll be updating our majority, so 1 is been updated here, so and with the count 1. Okay, 1 is 1 with the count 1, correct? Now we are at this position, now we have 2, so that value is different from this, correct? So we'll be updating basically decreasing our count variable from here to here. Okay, now we have the 0, so up to this everything is nullified. Now whenever we are up to this position at the last, we can see we have count equals to 0, so whenever we have count equals to 0 we'll be updating our majority element with the last element, which is 2. Okay, so 2 has been updated with the count value 1. Now whenever when we end this program, when we are ending this for loop, we are having some answer in the majority element and we'll be using that as a answer. So that's a basic Moore's algorithm. Let us try to write the code for this. So let us write the code. So we'll be having two things. One is majority element, so initially it will be nums of 0, and then we'll be having a count. Initially it will be 1. Okay, initially it will be 1. Now we'll be running our for loop. We'll start our iteration from 1. It will go up to the length, nums dot length. Okay, nums dot length, sorry for that, length. Okay, and then we'll be incrementing our I. Okay, now we need to check two conditions. That first, if our count is 0, then we need to update our majority. Okay, majority to that value. Okay, it will be nums of I. Okay, And in other case, if we need to update our count, so our count will be something like if majority equals to our nums of I, then we need to increment our count, so we'll be writing count plus plus, else we'll be doing count minus minus, is count minus minus. So that's it. And now once we are done with this, we just need to return majority. Correct. So whenever we are getting count equals to 0, so at that position whatever the value will be, that majority will be updating that with the nums of I. Count will be depending upon the majority element. So if it majority element is there which is equals to nums of I, okay, basically we need to do comparison like this. If majority element, if nums of I equals to majority element, right? If that is the case, then we'll be incrementing our count, otherwise decreasing. Let us try to run the code. It works fine for this. Let's try to submit the code here. So we are getting wrong output for this one. So here we did a mistake of doing this. Actually we are already updating count, so we just need to do something count plus 1 and here count minus 1, and we try to run the code again. It will work for this one as well, and for 655 also it will work. Okay, so that's it for this video. I hope you got the idea. We'll meet in the next video with another such problems.